we are Team 45. Our project is Advanced Language Recognition. To In this project, we have taken on the challenge of classifying toxic comments and making sure that it can be used in like social media platforms to fight hatred and identity crimes. So um, yeah, approximately 21% of the tweets have been exposed to cyberbullying, and many people are affected by this. So our objective was to take comments from the Wikipedia comments dataset and classify it into 6 different classes: toxic, obscene, severe toxic, insult, threat, and identity hate. And you can see that each comment can belong to multiple classes. For example, this first comment here is toxic and it is a threat, and the third comment here is a toxic, threat, and an insult to somebody. So what we can do is we can perform classification on each classes separately, and then we can find out the probability of that comment belonging to this toxic class or a threat class or an insult class. So initially we started with experimental data analysis, and in that data analysis we found that the many words are actually not distinct when it comes to separating like clean comments and toxic comments. For example, the word good appears in both like clean comments and toxic comments. So we need a model that will be taking into account these factors, that a word can be used in a like good context and a toxic context. So furthermore, the classification, the dataset's class distribution was fairly skewed because we got a lot of toxic comments and very less threat comments. So yeah, let's dive forward to find out about the baseline. In our baseline model, we use the naive Bayes model. This is a very excellent classifier, and for this classifier, we use the one versus rest approach, and the classifier was performing pretty good, except in certain cases, and this is very sensitive to outliers, and it has like assumption of independence, and it has a lot of class imbalance, and naive Bayes did not perform well when these factors came into play. So what we did was we looked forward and implemented a LSTM model, and in this LSTM model we used the glove embeddings, which were trained on like 6 billion tokens, and it would output a 50-dimensional vector. In the approach of classifying these comments, we followed this flowchart, and initially we were doing all like text processing, pre-processing, and then after the EDA we were doing feature engineering, which is where we use the glove embeddings to convert raw text into tokenized words, vectors, and while modeling we would use the LSTM model to predict the probability. So here is our proposed model, and we use like a bidirectional LSTM because the context can be from like the previous word and from the word that is after the current word. So we have done that, and then in the next model, and then like this is our classification approach. And in terms of pre-processing, we were using things like retaining case structure, removing URLs, and remote punctuation. We have used TF-IDF vectorizers to convert and tokenize the initial string to put into a meaningful machine learning consumable vector. And then when we evaluated the model, we found that the LSTM model performed at least as well as the naive Bayes model. However, this LSTM model, if even though it performs better than the naive Bayes model, we could see some issues with class imbalance, particularly if you note that this threat, we can see that none of the samples were being predicted as a threat message, and this could be due to a number of reasons, and this is one of the challenges of our model. So if you see the balanced accuracy for all samples, uh, the model performs comparatively poorly. And to overcome these limitations, we could have used SMOT, and we could have used class weights for training the data. We could augment the data and represent each of the samples equally, and that could be very useful when fighting this data imbalance. And that is all for our project. Thank you.